Welcome. Today we explore TRIZ, the theory of inventive problem solving, a methodology that transforms invention from an art into an engineering discipline. Spent 40 years analyzing over 400,000 patents and found something remarkable. The same fundamental contradictions recur across centuries and industries, and the same inventive strategies resolve them. The result is a toolkit, including the 40 inventive principles, the contradiction matrix, and the ARIZ algorithm. That lets any practitioner search the space of good solutions systematically, without depending on random inspiration. The fundamental problem with conventional innovation is that it depends too heavily on the right person having the right flash of insight at the right time. Brainstorming sessions tend to produce ideas clustered around what the team already knows, which is exactly the region of the solution space that is most overexplored. Worse, deep domain expertise can become a trap. The more you know about how things are done, the harder it is to imagine how they could be done differently. TRIZ addresses all three of these failure modes by providing a structured process that is both teachable and replicable across teams. Began his systematic study of patents in 1946 at the Soviet Navy's Patents Bureau. His central hypothesis was that inventive progress is not random, it follows patterns. Over 4 decades, and his collaborators analyzed between 400,000 and 3 million patents across every conceivable engineering field. The pattern they found was striking. The same fundamental contradictions recur across industries, time periods, and cultures, and a relatively small set of inventive strategies, which he eventually, as the 40 principles, accounts for the vast majority of successful resolutions. By 1985, ARIZ had reached its final revision, and the modern TRIZ toolkit was complete. The most important concept in TRIZ is the contradiction. Observed that whenever a problem is genuinely difficult, it is because improving one aspect of the system necessarily degrades another. He called this a technical contradiction. There is a deeper form called a physical contradiction, where the same parameter of the same element must simultaneously have opposite properties. A needle that must be sharp to penetrate and blunt to avoid damage is a physical contradiction. The key insight is that engineers typically respond to contradictions by seeking a compromise, which produces a mediocre solution. TRIZ insists on resolving the contradiction completely, which is where genuine invention happens. Once you have identified the contradiction, TRIZ asks you to define the ideal final result before generating any ideas. The IFR is a thought experiment. If the system could solve its own problem, with no added cost, no new components, and no adverse side effects, what would that look like? This seemingly abstract exercise does something powerful. It anchors ideation at the highest possible ideality level and immediately exposes the most elegant direction to search. At ideality level 3, the ideal solution is one where the problematic component ceases to exist entirely and something already present performs the needed function. Needle-free injectors are a perfect example. The needle is replaced by a pressure field, and the contradiction vanishes with it. TRIZ provides 2 additional analytical frameworks beyond contradictions. Substance field analysis models any engineering system as an interaction between 2 substances mediated by a field, where substance means any object and field means any form of energy. When a system fails to perform its function, field analysis diagnoses exactly which element of the interaction is missing, harmful, insufficient, or excessive. 76 standard solutions then map each deficiency type directly to a validated structural fix. Separately, the 8 patterns of technical evolution allow engineers to anticipate where a product or technology is headed, because systems don't evolve randomly either. They consistently follow trends toward greater ideality, increased dynamism, and finer-scale energy interactions. Analysis of patents led to a 5-level taxonomy of inventions that has profound implications for innovation strategy. 77% of all patents, the overwhelming majority, represent level 1 or level 2 solutions. improvements that any competent engineer in the field could reach with existing domain knowledge. The genuinely transformative inventions, levels 3 through 5, require reaching outside one's domain. A level 3 inventor must know what has been done in other industries. A level 4 inventor must draw on knowledge from other sciences. This is precisely the capability that TRIZ tools are designed to provide. Systematic access to cross-domain knowledge without requiring the solver to personally master every adjacent field. The 40 inventive principles are the tactical heart of TRIZ for idea generation. Each principle is a generalized inventive strategy that has been abstracted from its domain of origin and proven to work across many fields. Principle 10, preliminary action, is equally applicable to pharmaceutical drug preloading, software request prefetching, and industrial preheating. The same logic appears in completely different domains. The contradiction matrix is a 39 by 39 grid. You find the engineering parameter you want to improve on one axis, the parameter that worsens on the other, and the cell gives you the 1 to 4 principles most statistically likely to resolve that specific conflict. This is not brainstorming. It is a search guided by a century of inventive precedent. When the 40 principles and the standard solutions don't yield a satisfactory concept, TRIZ provides ARIZ, the algorithm of inventive problem solving. ARIZ 85C, the current version, consists of 9 parts and 85 analytical steps. It takes the practitioner through a progressively deeper examination of the problem, starting from a plain language description, forcing it into contradiction form, intensifying the conflict to its physical extreme, surveying all available resources, and consulting the effects database for relevant physical and chemical phenomena. ARIZ is demanding. It can take days on a single problem, but it reliably surfaces solutions for contradictions so deep that no amount of brainstorming would find them. The key discipline is to use ARIZ only when simpler tools have genuinely failed. The contrast between traditional brainstorming and TRIZ as idea generation tools is stark. Brainstorming generates many ideas, but produces them in an unstructured space with no inherent quality filter. The team must evaluate everything afterward, and the ideas tend to cluster around familiar solutions. TRIZ inverts this. It first narrows the search space to the specific contradiction that must be resolved, then points to the principles most likely to work. The result is fewer ideas, but dramatically stronger ones. Crucially, TRIZ also forces cross-domain analogical reasoning. Principle 13, inversion, doesn't care whether you're designing an engine, a business process, or a medical device. The two approaches are actually complementary. Use TRIZ to identify the right direction, then use brainstorming to concretize the abstract principle into domain-specific concepts. 4 cross-domain case studies show how TRIZ works in practice. The Boeing 787's windows resolve the physical contradiction that aircraft windows must simultaneously be large for passenger comfort and small for structural integrity. By electronically controlling light transmission, the window is large in area, but functionally small on demand. Thixotropic drilling muds resolve the viscosity contradiction by being thick at rest and thin under shear, separated by operating condition. In software, predictive precomputation separates the latency throughput contradiction in time. And needle-free injectors dissolve the sharpness contradiction entirely by eliminating the needle, the clearest expression of ideality level 3 possible. Let me close with the essential message. TRIZ does not make invention easy, it makes the search for good inventions systematic. The single most important habit it instills is contradiction thinking. When a problem is hard, ask what must be true and simultaneously not be true, then resolve that tension completely rather than compromising. The ideal final result stops you from settling for good enough. The 40 principles and the contradiction matrix give you a map of proven solutions across the entire history of human invention. And ARIZ is there for the truly intractable cases. Engineering challenges are growing more interdisciplinary, and the cost of failed innovation is rising. TRIZ gives teams the tools to navigate that complexity with rigor, without waiting for a genius to walk through the door.